Hello everyone, a very warm welcome to everyone present over here. Myself Priyanka, I'm a team member at Hack the Mountains. So Hack the Mountains 2.0 welcomes you all for the 17th session of Qubits. It is really nice that all of you have taken off your time to attend this session to learn something new. Let's continue having the spirit for this event and also for the upcoming events. We welcome you to another highly exciting session on the topic Introduction to Blockchain and Ethereum with Pranjal Bhardwaj. Here is your chance to be introduced to the world of blockchain and Ethereum. This session is dedicated to all the new beginners and help you dive deeper into blockchain and Ethereum and start your own path towards your career and all other topics. Pranjal Bhardwaj, our speaker today, he is a community founder and lead at Ethereum India, also the CEO and co-founder at Collabrains, community lead at Hyperledger and a blockchain speaker. His experience on this very field makes him more than qualified to introduce you to blockchain and Ethereum. So Hack the Mountains team welcomes you all once again, and Mr. Pranjal, over to you. All the stage is yours now. Thank you.
Thank you so much for that lovely introduction. I should start by thanking your team for inviting me for the event. I've seen you guys organizing a lot of different webinars, and that's really great that all the people who are involved in this, who are participating in the hackathon, they'll get to learn a lot, and they'll be able to improve their skills and they'll be able to work on them. So yeah, let's start with the today's session. I'll just share my screen. Yeah. Okay. Guys, please let me know if my screen is visible. All right. Okay, let's start by just I would like to learn more about the audience today. So I would like to understand if you guys are experienced about blockchain, if you have heard of it, if you have actually worked on it, or what type of experience do you have with blockchain? So you can tell me if you're just a beginner who has just heard of this term, or if you actually know about the technology and like to learn about the advanced concepts, or if you have actually built full stack projects and you know a lot about it. Please just type it down in the chat box. I would love to know. So introduction has already been done. We can start with the main topic. Uh, okay, let's start with the basics of blockchain. So, I mean, I've seen a lot of people confusing blockchains with the cryptocurrency Bitcoin. So, I would like to address that first. Like, blockchain is a technology, while Bitcoin is just a coin. So, I would like you guys to know that there's a huge difference. And let's start by learning what is blockchain first. So blockchain can be defined as a sequence or a chain of blocks which contain some certain information. So this information which is carried on these blocks can be really useful data. This can be really important files that we want to store securely. This can be any sort of different information which is really important to store in a secure manner. That's why we would like to make a that's why we'd like to store it in different small blocks, and we like to make a chain. Like we would like to link them in a chain. So that is the very basic definition of blockchain. So when we talk about like the fundamental concept, you can clearly see like through this image, we can see three blocks which are linked to each other, and they have a fingerprint like impression on them. Okay, so yeah, beginner. Okay, it's fine. So yeah, we can see through this image that there are three different blocks with some what do you call it? Some fingerprints on them, and they are linked to each other. So what these fingerprints signify? These fingerprints actually mean that these blocks are very unique. There is if I consider block number one, then it will have a unique fingerprint, and if I consider block number two, it will also carry a unique fingerprint. And if we consider a chain of infinite blocks, there won't be any two blocks with the same sort of fingerprint or same unique identity. So if you're getting my point, then you'll understand that all these blocks are unique in a way. They have their own identity, and if one of them goes missing, we would know that, and we can tell which particular block or which particular part is missing. Okay, so let me just explain you some details in this. So what happens is, you can see in the second block, you can see there's actually two fingerprints, and we can see in the third block there is also two fingerprints. So what happens in blockchain is, when we try to store data, we have just the first initial block, which contains a unique fingerprint, or we call it a hash. So hash is this unique number which is associated with the block, and this number is actually the unique identity which the block is now given. So in order to link that block to the next block, what we'll be doing is, we'll be storing the information about the hash of the previous block in the new block. So basically, in the second block, it will be carrying two fingerprints, or the two hash functions. So it will be having its own hash function. Also, it will be having the hash function of the previous block. So what we can understand from this is that this will contain the information of the previous block. So they are sort of connected to each other. And if this block goes missing, then we would know which block is missing by just extracting the information which is present over there. So yeah, similarly, if you talk about the third block will be containing the hash of the previous block, which is the second block. So in this way, we sort of link these blocks together, and later on in the session, I'll tell you what is the difference between, like, what is a nonce block, what is the first block in this chain, and what is actually hash function and how we actually generate hash functions. So yeah, so we'll be diving into that. Uh, so moving on, as I said, blockchain versus Bitcoin. Many people often confuse the concept of blockchain with Bitcoin. Many people think that the fundamentals of decentralizing something is actually Bitcoin. But when we talk about the fundamentals, blockchain is the core fundamental which tells us that something can be decentralized and something can be stored in a decentralized manner. And when we talk about a currency which works on this decentralized system, so basically a digital currency which will have the fundamentals of blockchain, that is Bitcoin. So essentially, what's happening here is, Bitcoin is just using the concepts of blockchain. So Bitcoin, the concept of Bitcoin surfaced around in the 2008 2010 time, but the fundamentals of blockchain were there in the 1950s and the 40s. The scientists have actually thought of this technology which can be formulated in a way that there's just not one central authority who has the access to all the data, and which has all the power in one particular system. So that is why, based on that concept, some people who are actually thinking that the governments are holding a lot of power when it comes to the currency, when it comes to the asset. So then they thought of making a digital asset and moving on to a digital currency that we know as blockchain, that we know as Bitcoin. So that is the fundamental difference between Bitcoin and blockchain. Bitcoin is just based on the technology of blockchain. So yeah, so that is a very fundamental difference that you need to know and you need to remember. Yeah, moving on to the different components of blockchain. So when we talk about different blocks in the blockchain, not just blocks. When we talk about the blockchain, there are different elements and components to it, which makes which actually makes it possible for us to create this sort of a decentralized system. So what are those important components? So number one, we have node. So node uh, is actually a unique computer, or a user which is present within the blockchain. So there are a lot of miners, there are a lot of validators, there are a lot of network validators who are present on the blockchain, which acts as a node. So so let's take example of a of the paper currency. Let's take example of the US dollar. So the node which is responsible for circulating the US dollars is actually US government. So they are the they are the central authority who is responsible for for printing those notes, and we can say that they are the nodes, and they are the people who are responsible for validating the nodes. So, in the same way, on blockchain, the people who are responsible for which are present on the blockchain, there are a lot of different roles that they can perform, but overall, they are known as nodes. Then there is something called as transaction. So, transaction is just a little meaning of just maybe a transaction between two people. So when we talk about transaction, it's just the smallest building block, because uh, in order to establish a connection between two blocks, there will be some give or take. There will be some sort of connection between the two, and the connection which is required to facilitate that connection is known as transaction. So that is the transaction part. Now coming on to the block. So block is that smallest unit which holds certain data on the blockchain, and we try to create this huge chain of different blocks. So these are just data structures stored in a very small form, and these are linked through transactions, and these are distributed to all the nodes. So all the nodes have the access, and they have a copy of these blocks and all these data. So if there are suppose two people on the blockchain, two people are on the node, there are two people are the nodes, then they will be having information about all these transactions, which is maintained in form of a ledger. We'll have the information about what the data is, which is essentially the block. Yeah. Then we come to the chain. So chain is just like transaction. I told you transaction is responsible for linking of the two blocks, but when we talk about the chain is the uh, is the is the fundamental concept which is responsible for letting us know, like, in what sequence do we have to arrange these blocks, like in what sequence these blocks has to be arranged, and they have to be connected. So in order to connect these blocks properly, we need the concept of chain, how we're chaining these blocks. Then moving on to the miners part. So miners are some specific people, some specific nodes which are responsible for the block verification process. So when we are adding these new blocks to the blockchain, it is not entirely true that all these blocks are actually genuine. There can be some problematic people who would try to maybe generate some malicious code, and they would like to deploy them on the blockchain. So in that case, this miners will be validating the block. If the block which is mined is actually proper or not, they will be doing this verification process. They'll be running different checks. And when we talk about consensus is a set of rules and regulations which is formulated for the people who are using blockchain. So anyone who is involved in the operations which are done on blockchain have to abide by these set of rules and regulations. If you are not relying to these rules, you will be kicked out of blockchain, and there will be some sort of a hard fork, or the chain splitting, and you will be removed out of the blockchain if you don't give consensus to these set of rules. So the consensus is written by the people who are making the blockchain. So they are responsible for formulating what type of different rules they want on their blockchain. So it's totally up to them what type of rules to define. Moving on to the different components, as I told you, the data which is present on the block. So, like, we understood, like, there are components of the blockchain. Now we're talking about the components of the block. So these are the data structures. So we have three things in this. We have data, we have the hash of the block, and hash of the previous block. So I told you a little bit about this in the first slide itself, but I'd like to explain it again. So as I told you about, like I explained to you in form of a fingerprint, a unique sort of uh, code which is given to the particular block. But in this case, we can specifically see that there is a unique code, there is a unique hash which is given to each and every block. So all the blocks have a particular hash, and when they're connected to the new block, the second block will be carrying information about the hash function of the previous block, and they will be having their hash function of their own. And if they get connected to a block number three, then the hash of the block number two will be shared with the block number three, and then they will be carrying two hashes, their own hash and the previous block's hash. So in this way, we can see there's some sort of an interlocking by sharing the hash of block number one with block number two, and hash of the block number two with block number three. So in this way, if suppose block two was supposed to be just taken out of the blockchain. Let's say I'm a hacker, I try to remove this block number 2 out of the blockchain. Then block number 1 and 3 will link, and what we'll see is the hash given here is 6U9P2, but the hash which is supposed to be here was 8Y5C9. So this doesn't really match, because the fundamentals tell us the block of the hash of the previous block is supposed to be stored on this, but it doesn't really match. So that is how we know that there has been some sort of tampering which is done in the blockchain, and there is some sort of problems which is considered, which is there on the blockchain, and we would know that there has been some sort of manipulation which is done. So in that case, this provides a lot of security. If we want to store some data, this would provide us a lot of different scaling solutions, and there can be a lot of use cases of this. Now talking about the genesis block. So in the previous diagram, we can see block number 1 does not carry hash of the previous block because it is the first block in the blockchain. It is the first block and does not have uh, information about the hash of the previous block. It just has the hash of its own. So this block, which is the first in the blockchain, is known as the genesis block. So this block, like as I said, the first block in the blockchain is called the Genesis block, and this first ever Genesis block, when we talk about Bitcoin, was mined by Satoshi Nakamoto in 2009. So Satoshi Nakamoto is considered to be the founder of Bitcoin, but we never really got around to finding who that person is, because that person remained anonymous for a long time, and there were some claims that this can be a group of people who have done this, and they've just chosen to stick with a really anonymous username and all those things. There are a lot of different theories around it, but yeah, we can definitely say that the first block which was mined and which was actually part of the blockchain was set up by Satoshi Nakamoto, and uh, in case of Bitcoin. So if we want to find the genesis block, what we'll do is we'll just pick any of the block in the existing blockchain, and we would try to go back in the sequence. We would just try to go back and back and back, and we'll just try to find which is the block which does not have the hash of the previous block, so that we will know that this is the genesis block. This is the first block in the blockchain. So yeah, we will eventually arrive on the genesis block. Now coming to the blockchain structure. So as I told you guys, this is a very decentralized form of storing data. So we can call this as a decentralized peer-to-peer connection, which is happening over here. So let's say if you want to take an example of let's take an example of BitTorrent. So what happens in BitTorrent is there is no central server with the movies or whatever data is stored. There is actually the data is actually distributed between a lot of people, and this data is shared by them. If I want to download it, I will just request each and every person to give me that part that they are holding it. So they'll be giving their parts, and I will just basically combine them, and I'll have the whole movie or the whole data. So similarly, what happens is in blockchain, there is a peer-to-peer decentralized connection. So if I want to make transactions with anyone, there is there are a lot of advantages if I want to just transact with a particular block. There is no intermediary between us, so it is a direct connection between both of us, and there are a lot of advantages to it. But at the same time, because it is based on peer-to-peer transaction, and people would like to transact with each other quite often. So there are some problems that we inquire in future, like currently Ethereum is facing a lot of problems with the transaction scalability. So currently, there is a lot of delays on the network if you try to make some transactions. So in order to solve that, there are a lot of scaling solutions which have come up to fasten those transactions, to make this peer-to-peer connection a lot more faster. We can see the example of Matic, which is trying to implement the Ethereum Plasma protocol, and provide a layer 2 solution to it. If you talk about Ethereum, then the transactions per second right now is like very less, but with the upcoming Ethereum 2.0 update, they'll be moving to the proof of stake, and they'll be moving to different sort of they'll be doing some shardings, and basically we'll be arriving at around 15,000 transactions per second. But currently, Matic is providing around 65,000 transactions per second, so which is like really a lot in comparison to ETH 2.0 if it gets implemented, which has already been delayed a lot of times. So in that way, there are a lot of scaling solutions which has come up to just to basically uh, scale these transactions and scale this peer-to-peer connection. Okay, let's move ahead. Yeah, so this is just a basic diagram for you to understand the concept of blockchain a little better. So let's take one example of a bank. So as I gave you example of US dollars, the currency is being regulated by the US government. So we can assume this to be the US government in the center, which is responsible for distributing money to each and every different money like different banks and basically circulating their currencies among the population. But in case of blockchain or in case of decentralized systems, what we have is we have different nodes which are responsible and they are connected with each other and a lot of different peers. So in this system, we can see that there is no one central authority. There are a lot of people who are responsible for a lot of small tasks, and they hold information about different things, and these data can be very easily shared between them. And the biggest disadvantage of centralized system is that if the centralized authority fails, or if they want to basically, like, let's say if the US government one day they decide that we will be controlling the system from now on, we will be responsible for whatever, like we will be doing as we want. We are not going to listen to any people or any other private organizations, then we can't really question them. We can't really go ahead and say that how can you do this. But in case of decentralized systems, we get the surety that it is a network for us, and we are actually involved in this network. There's no one who is having authority or who's having control over us, and it gives a sense of freedom and uh, a sense of collaborative effort in this decentralized system. So yeah, now coming to the database versus blockchain. So a lot of you guys must be thinking that what is the difference between database and a blockchain system. So when we talk about databases, these are like centralized servers. Let's say there's a company called Wipro which has a server set up in Chennai. Now they will be having multiple servers which are set up in different parts of the world or parts of country. So they will be pulling information from one part to the other, and it is really hectic. But what happens on the blockchain system is there is no central authority. The, there's no one central place to store the data. There are a lot of different small, like there are a lot of small nodes which have the information. The information is which is equally distributed among all the people, and this data is spread throughout the blockchain, and all the blocks have they all carry some sort of information uh, which is essential, and it will offer more security if you think about it, because if a hacker wants to just if they want to mess with the company data, if they want to just uh, extract the information which is really confidential, they would just attack the main server and they will get the hold of the data. But in terms of blockchain system, they can, maybe they'll be able to surpass one security system. They'll be able to hack into one computer, but they won't be able to hack into thousands of or billions of millions of computers, because there'll be a lot of people who are present on the blockchain. And, it won't be I mean, it's possible, but it won't be feasible for them to do it, within a given time period. So so in that sense, it is very secure, and it is very much better in comparison to traditional way of storing data, or traditional databases or servers. So yeah, okay, moving on to the advantages of blockchain. Like I've already been through a lot of advantages throughout the slides, but I will be mentioning them all at once. So number one is the time reduction. So let's say I want to send someone some money, and I'm making a transaction of, let's say, five to 10,000 rupees. And let's say my bank is not supporting the payment right now. The bank servers are under maintenance, and they are under a lot of pressure. They won't be able to facilitate my transaction, and they'll be actually canceling my transaction, and I'll have to do it again. So in that case, there's a lot of time which is wasted. There's a lot of effort which just goes waste, and this transaction doesn't really work that well when we talk about the traditional systems. But when we talk about blockchain, we can make instant transactions considering it's an efficient blockchain. Right now, we can make some transactions using Ethereum in minutes. Uh, 5 to 10 minutes, we can deploy some we can deploy some smart contracts. We can just run and do some transactions. But uh, yeah, in compared to the traditional bank systems, it is far more reliable, and it works way better than their systems. So this gives us a sense of reliability. So we'll be relying on the system a lot because we know that they're very safe, and there's no harm in using them. Since uh, you know uh, if I want to make an urgent transaction and if the bank server is down, then I can't really do anything about it. But the blockchain never goes down. There are a lot of people in the blockchain at all times, and they will be able to facilitate the transaction, and I'll be able to actually send in the money that I want to send to some other address. So yeah, number third is fraud prevention. So there won't be any middleman which is trying to gather my data, or which is trying to try to steal my money, or do some sort of a man in the middle attack. There won't be any sort of hacks happening over here, and this gives a lot of security to the system because no one can just come in and tamper the system, and no one can just come in and hack just one machine and the whole system goes down. It's not gonna happen. Now coming to the transparency, because we don't really we don't really know what goes on in big banks if we store our money over there. If we give our money to the bank, if we park some money and we just give some deposit, we don't really know if our money is being stored somewhere, if it's given to some other people as some form of loan, or what has happened to the money. We don't really know about. But there is this form of transparency that we have when we talk about blockchain because all the data has been recorded. Every transaction is actually noted, and there's a proper ledger which is maintained for these transactions. So at any point, if I want to know about the details of the transaction I've done in the past, or if I want to know about details about the senders, I'll be able to know that. And if I'm actually doing some transactions of bitcoins, I'll be able to track who was the previous owners of the bitcoin. In that way, I would know like how many people have owned it, and I would like to know like I would be able to get all the information about what kind of transactions have been done on that by that person, you know, but just by knowing their private addresses, their public keys. So yeah, that is really important and that is really useful. Now coming to the just the basic points of collaboration and decentralization, as I've said, that these decentralized systems offer a lot of reliability, and this is a whole new system of storing data and managing people on the network. So this is really useful when we talk about about modern systems of and modern architecture of storing data. So this is a really game changing technology, and we can store data in a very efficient way. Okay, do you have any doubts? Like you can just put in the chat box, and I would love to answer that. Then we can move ahead to the blockchain use cases. Hello everyone. Hello everyone who has just joined the session. Okay, I haven't seen any questions, so we just move forward with the session. So next we have the blockchain use cases. So you just got to know about what it means and how we can use it, but how are we actually using it in the real world and how we're actually trying to implement this technology in the real world. So it is really exciting. So when we talk about the markets, we have done a lot of implementations in terms of markets and in terms of supply chain. So there are a lot of there are a lot of advantages when we talk about markets because it has given a lot of use cases for us, and it solves a lot of problems. Uh, when we talk about the supply chain network, uh, it is one of the revolutionizing things, and it is like one of the projects that you might know of is WeChain, which is trying to solve the supply chain logistics, and a lot of companies have backed it. Companies like Walmart and BMW has backed it because what happens is supply chain is we'll be knowing what data is being transferred, and when the if we can associate every product with a unique code or a tag, and we can just scan it to know like what are checks that that particular product has been passed on to. So like if someone is claiming that this chocolate has been made in Italy, we can just scan it and know like if what was the starting point of this of the raw products. We would like to know like we would know that like when did this chocolate arrive in the country, when was it was stored in the warehouses, and when we got it, when we actually got it. And we would like to, we would get to know about a lot of different data which is there about the specific product. Now, so this will offer a lot of flexibility in the terms of markets and in the retail world. So yeah, that's a huge case, these use cases. So moving on to the government sectors, when we talk about the voting systems, when we talk about the digitization of voting system, it's one of the concepts which can actually change the system, because uh, what we currently see is just people blaming each other for rigging elections, and just changing a lot of they're just saying, they're just complaining about someone rigged the system, or someone is trying to cheat in the elections. But it is not possible when we talk about government sector, because uh, which is not possible in terms of voting, which is done on blockchain. When we because we'll be verifying all the users which are on the which have signed up for the voting, right? We will be actually verifying the identity of the people who are doing it, and we will be able to securely store all that information on the blockchain. So that is a huge case now use case now. When we talk about IoT, so in terms of agriculture, and in terms of drone sensors, and all these smart home sensors, a lot of different things have been done. So technologies like like creating a mesh network, and doing all sort of things in smart homes, and things, and a lot of research has been going on in this field. And there's a huge overlap between IoT and blockchain, and a lot of people are actually researching about this. Now coming to the healthcare part, there's a huge use case in healthcare specifically, because when we talk about the medical reports, or when we talk about the sensitive data about the patients, it's really important to to store that securely. Like we have seen traditionally hospitals storing that data in uh, you know uh, just storing it as files in in their offline storages. But like they've started digitization of these files, and maintaining a patient record for future references. But if that medical data is actually leaked, and if someone gets to know about the specifications of a particular patient, then it will be a really big problem for us. So what we can do is we can sort of secure this whole system by just safely deploying all the data on the blockchain. And in this way we'll be able to have a secure system where all these information has been stored, and no one will be able to like no one will be able to access it if they don't have the access to it. So yeah, so coming to the science and art, so recently we have seen there's a huge boom in the field of NFTs, and people are creating their art, and they're just trying to sell they're just trying to sell it on a lot of different online marketplaces. So there's a huge use case in this, because when they're trying to create an NFT, there's what they're doing is they're making sure that this particular art is unique, and a lot of people will be interested in buying them, because if we can look at it as some sort of asset which can be used for effective investment. So in that case, a lot of people like to invest in those, and a lot of people are actually NFT collectors, and a lot of different companies are actually giving loans against those particular holdings that people have. Like if someone is holding a painting, or which is an NFT art, they would be getting some sort of loans and compensations against it, and they can actually resell it for higher prices. So we have seen crazy prices for these NFTs, and there's a huge use case in arts. So yeah, there's the science and art. Then we talk about the finances. So when we, this is like the decentralized finances is the biggest thing that we have seen for blockchain, because in terms of decentralized finances, we have seen secure payments. We have seen a lot of banks adopting the blockchain technology for their own transactions. We have seen big firms like JP Morgan and Goldman Sachs actually working, and they have some divisions which are responsible for researching about how should we improve this, and how we can make it better. People are actually They have recognized Bitcoin as a unique asset, and they are trying to understand what all can we do with this, and what can be done with the blockchain technology. And we have seen huge use cases in this field. So payments and, like, in general, the biggest use case is payments in the financial sector. We'll be moving on to the Bitcoin, and some like, basics of Bitcoin and the components of Bitcoin. Just some basics about it. Yeah, so when we talk about IoT with blockchain, what we have seen is mostly, uh, some sensors which are integrated in the systems with blockchain. So when we talk about tracking some systems, like the tracking systems, when we're trying to track some products, what we have seen is, like, we can integrate these sensors to basically scan the products and know, like, we can, like, if I'm trying to upload the information about certain product on the blockchain, I can just scan it using some IoT sensors, and the data about that particular product will be stored on the blockchain. So in this way, there's a huge use case, because when it comes to, specifically when it comes to food industry and food products, the food is supposed to be fresh, and people should know when this was processed, and what is the expiry date for this, and uh, what is the details about this product. So in that case, it is very useful for, if they try to store this information in the blockchain, and if the company is transparent enough to give out this information to their customers, it's a huge use case. Okay, moving on to Bitcoin. Now, Bitcoin is, as I told, it's a currency system which is based on blockchain. So what we have is this network which runs on the blockchain protocol. So we have this asset which can be transferred to anyone, which we can do different transactions with this, and this concept is basically about a currency which is not regulated by anyone, and the people who are actually holding the currency will be responsible for the for everything related to the currency. So if there is something which, if someone is proposing a new feature which can be added to the Bitcoin system, then they can just do it, and if majority of the people agree to it, then that feature will be implemented. And there's something that we can see we can only see in blockchain. We can only see it happen in Bitcoin, because when we talk about traditional governments, or when we talk about governors who are actually responsible for who have these powers of circulating the currencies, they won't really listen to the people. So in that way, it is really good, and this Bitcoin can be used for transactions in a regular day-to-day basis. So yeah, so we'll come to that now. Just so you know, it follows the proof of work model. So the people who work to basically get the Bitcoin, they will be rewarded with something, and in that way, is there any tech currently where we can create smart contracts for Bitcoin? Yeah. So basically, we deploy our smart contracts in Ethereum. So what we do is, like, let's consider a web application. So we'll be having a front end and a back end. Back end holds some logic about the functionality of the web app. So what we can do is we can just replace the backend code with the smart contracts. Smart contract is essentially a logic that we'll be coming up to we'll be exploring smart contracts over here, but I'll just like to tell you in short. We'll be having these smart contracts which act as a logic, and we can deploy these smart contracts over the Ethereum blockchain. So Ethereum blockchain currently has you know, a lot of projects running on it, and if I want to deploy any project, I can just write a smart contract for it, and I can deploy it on the testnet, and just eventually move forward and test it on the mainnet. So Ethereum has made it really possible for us to deploy it over there. There are a lot of different other blockchains which are coming up with smart contract. It's dedicated smart contract languages and compilers. We can see that in Cardano. We can see that in a lot of different projects which are actually trying to improve that, and they're trying to uh, they're trying to implement the smart contract side of things. So yeah, so I hope that answers the question. Yeah. So uh, like why do Bitcoin have value? So when we talk about Bitcoin, it is essentially a it offers us uh, of it offers us flexibility in terms of transferring money with each other if we want to make some transactions. We don't have to rely on any third person. We can do it using our decentralized network, and there is the transaction that we do, and if you're sending money to someone, there's the fees are minimal. We are not paying around 2.5 or 2% of the transfer fees to any third party. So these fees are very minimal, and uh, these fees are very minimal, and these the transactions can be carried out with the help of Bitcoin. And when people have trust in this system of transferring money, then we would know that this asset actually holds some value, and that's why people invest in Bitcoin, because they think it's an asset, it's a hedge against your inflation, and people like to hold this asset. So it will definitely have some it will definitely hold some value after a point. So yeah. Now, what are the different things that we can do with bitcoins? We can obviously purchase bitcoins. We can go onto exchanges. We can exchange bitcoins. We can a particular person can mine bitcoins if they have enough computing power. We can do transactions with it, and we have the concept of hashing, which is generating random generating new blocks for this. So yeah. Okay. Just a second. So when we talk about mining is basically a process in which a person is doing some computations, and they are just trying to add a new block to the blockchain, to the Bitcoin network. So if someone is mining a Bitcoin, they're just uh, they're just carrying out just different computations to find that particular hash of the new block. So it's a very graphic intensive task, and I'll be having very graphic intensive and uh, very computation intensive rigs and CPUs and GPUs to carry out these computations. It's basically a race to solve a mathematical problem. We can call the hash function as a complex mathematical problem, or a complex mathematical function that we have to crack for the mining to be successful. So that is how Bitcoin mining works, and uh, you know the first person who is able to do it, they get to record the transactions, and they eventually they themselves are the miners, and they record the transactions which happen on the block, and later on they get some rewards on the block, on that particular block. When some exchanges, or if let's say if some 4 or 5 transactions have been done on the same block, they will be getting the rewards as the mining rewards. So there are a lot of use cases for that. So yeah, there are a lot of benefits for that. So yeah, just check the comments if someone has any question. What about Cardano, and how is it different with Ethereum? Yeah, so Cardano is basically like there are mixed opinions about Cardano when people discuss Cardano, because the whole community around Cardano is really hyping the projects up, because it involves a lot more uh, like they're a lot more open when it comes to project and community building. So what we have seen so far is we have not seen any active projects from Cardano, but we have seen them actually discussing these projects with the people. And what we can consider the situation as a bunch of professors or a bunch of teachers coming together discussing about projects. But yeah, right now they don't have any active projects. Like we have just seen, we have just seen them implementing these systems and some blockchain systems in some of the African countries. So they're just trying to. So essentially, what they're trying to do is they are the competition of Ethereum, and they are trying to beat Ethereum at their game of providing some, just by different, just by creating an efficient form of Ethereum, by improving the transactions, by doing all sort of different things. But as of now, they don't have any project up and running, so we can't really say that if they'll have a good project in the future. But yeah, I think we can see in future that they can be a good challenger to Ethereum system. Uh, so they are trying to build a lot of smart contracts and protocols and DApps on their blockchain. So yeah, these are like really interesting technologies that a beginner can work on that. But when we talk about specifically about Ethereum, it is way more established as compared to Cardano. So yeah, that way it's way better. So transactions, as I said, Bitcoin transactions, as I said, it can be done from person to person. So person A can send X Bitcoin to B, and B can send Y amount of Bitcoins to C, and there is proper ledger which is maintained about this transaction, and one will be able to, they'll be able to know like where these transactions were done in the past, and in this way, we'll be able to track the transactions which were done. So yeah, so then there are keys and wallets. So what we have in this is like the fundamental concept behind keys and logic is we can consider your public key as a username for a particular person, which is on the blockchain, which is holding bitcoins, and they have a private key for their accounts. So this private key is sort of a password, which is required to access the wallet, which holds the bitcoin, and this password needs to be protected, and it needs to be secure. While the public key can be shared with anyone for making the transactions. So I can share my public key, which is the username. If I want someone to transfer me some money through bitcoins, I can just simply share my username. We call it the public key with anyone, and I'll be able to, they'll be able to make the transaction, and I'll be able to access it through that. So yeah, so that is about me. I'll just go ahead and tell you guys basics of Ethereum as well. Then we can wrap the session up. Should I learn about Hyperledger? Should I learn Hyperledger, and is there any use of learning it? I've heard a lot about it. Yeah, Hyperledger has a lot of use cases. The products like Hyperledger Fabric, Hyperledger Composer, and and these technical stacks, they are really useful in professional use cases. So what we have seen is we can build different type of blockchains. So there are public blockchains, there are private blockchains. So if a company is trying to internally implement a type of blockchain which is both public and private at the same time, like it can be public, like people can be on the blockchain, but they will be restricted to some of the parts of the blockchain, which is only there for the people who are actually working in the country, working in that company. So if you want to implement those sort of things. So basically, just in short, when we talk about industrial level implementations, Hyperledger has a lot of use cases. Hyperledger technology has it's really useful if you get to learn about it. We can use the projects for supply chain management as well. So like mostly I've seen people building tracking systems. I've seen people making all sorts of different tracking systems using this. So Hyperledger has a lot of different use cases, and it's something which is really useful for like a lot of companies are actually looking for Hyperledger developers. So yeah, that is like really important. And if you have the time, you should definitely invest some time in learning about Hyperledger. Yeah, so I'd say in terms of job opportunities, both Ethereum and Hyperledger have a lot of job opportunities. People are actually looking for some DApp developers, some people who have experience with deploying smart contracts, people who have experience working with Hyperledger and all these things. So there are actually a lot in there. So I'll just share my screen and talk a bit about Ethereum now. Um, just, just tell you guys the basic components of I'll just tell you guys about basic components of Ethereum, and later on you can just explore them by yourselves and build on Ethereum. So when we talk about the cryptocurrency which is related to Ethereum, it is called Ether or ETH, and it is a currency which is related to it. So whenever we want to do any sort of transaction on the Ethereum blockchain, we will use it as as the currency to do these transactions. Again, because if we are doing any transaction in the Ethereum network, we will be using it for paying all these gas fees and paying for all these transaction fees for the Ethereum network. And yeah, again, another feature is that it's a peer-to-peer currency, so I can just make transactions based on uh, over the Ethereum network using the. So yeah, now what is the need of ETH? So Ether can be used in building the decentralized application. So let's say if I'm trying to make a unidirectional payment channel, if I'm trying to make a bi-directional payment channel, I can easily implement it by using some sort of fake ethers. If we talk about the test nets, and when we actually move on to the main Ethereum blockchain, we'll be able to do these transactions with actual ether. So yeah, again, we need some sort of standardized currency to pay these gas fees when we talk about Ethereum network. So that's why we talk. That's why we have the Ether for paying our gas and computation fees for all the different type of processing which is there on the Ethereum blockchain. So now, so moving on to the smart contracts, which is like the biggest use case of it. When we talk about Bitcoin, it just offers us a currency, but basically we can implement the technology of decentralization to anything with making smart contracts and making these set of rules for them. So yeah, so as I said, smart contracts is a set of rules. These are the these are the contracts. These are like code which is written, and when this code when this code actually executes, the smart contract compiles and the transactions are made according to that. So yeah, so any user can create the smart contracts, and we can basically deploy them over the Ethereum blockchain. And what these smart contracts do they are actually a mutual consent and mutually agreed terms and conditions between people who are trying to do some sort of exchanges. If there's someone is trying to use my application, these smart contracts will be the rules and regulations about the particular application. There are some features about a smart contract that once it is executed, it cannot be altered. So a lot of tests are run on the test network to make sure that the smart contracts are proper. Uh, yeah, basically, smart contracts provide automated transactions for of they can be used for any sort of different use case. We can build different logics. Let's say if you're trying to if you have two people on the network, if you say the value of if you're trying to just randomly generate a number for each one of them, if you're trying to just give out a number for them, if I can define a statement saying if the number generated is greater than 8, then you have to carry out the transaction. So this code will always be there, and as soon as the number greater than 8 is generated, the transaction will happen. So it's really powerful in that sense. So another one of the uh, features of smart contract is it cannot be altered. So if someone is trying to mess with the code of the smart contract, it is not possible for me to just hamper it. So no, I cannot go and change those if else conditions. I cannot go and change those get value and set value functions inside of these smart contracts. So yeah, yeah. So when we talk about features, these are the like really important features. And smart contract is immediately rejected if the transaction, if they detect that something is going on which is not supposed to be going this way, and these smart contracts are immutable, so they cannot be changed. And yeah, and two anonymous parties can just make transactions using smart contracts, so it's very beneficial in that sense. So that was the smart contracts. Next we have the virtual machines. Now, these virtual machines are called the EVMs because they are called Ethereum virtual machines, and these operate as the runtime environment for Ethereum smart contracts. So we need something to compile these smart contracts, right? So basically, what we can't really code these smart contracts and expect the blockchain to understand on its own. So this is just a programming language. So this is just a compiler, we can say, which helps to convert the language which is written in the smart contract, to different languages which is understood by the blockchain. And using we can just upload this to the EVMs, and later on we can process them. And yeah, it is operating in the sandbox environment. Then the working of it. So what exactly convert, like what type of exact conversion that occur is, basically we convert our programming language into bytecode. So we often code our smart contracts in Solidity, Viper, different languages, but mostly in Solidity. So we will be coding our smart contracts in Solidity, and we'll be compiling them into bytecode using the EVMs. And this bytecode can be understood and executed by Ethereum. So using EVMs. So in that way, EVMs are really useful, and these are really powerful. And uh, you know, this is one really essential component of Ethereum, Ethereum's ecosystem. So yeah, now going on, just proof of stake. It's still under the process for the Ethereum 2.0. So we can just skip that for now. Let's talk about the DAOs. DAOs is next. This is the decentralized applications. So DApps are basically like we make a lot of different applications for the mobile phones. We make a lot of different web applications for our browsers to run, and to do different type of uh, you know for different applications, right? So we can do these different things for on a blockchain, and we call it the decentralized applications. So basically, the backend is replaced by the blockchain, and the data and the logic behind is basically written in the form of smart contracts, and it runs on the blockchain network which is there. So these DApps will be running on the Ethereum network, and yeah, so in that way, DApps are very useful. We are seeing a lot of different organizations which are hiring people to make different DApps, because people believe that DApps is the thing of the future, because essentially people will be moving on from just the decentralized uh, from the centralized applications to decentralized applications. So yeah, that's why. Uh, just a second. So yeah, but then we have the DAO, which is decentralized autonomous organizations. So these were just made by the by the founding people of Ethereum to basically have some sort of a hierarchical management, to basically so that if some important decision have to be made, these organizations can help in making those transactions, and making those things possible, without the need of a hierarchical management, without the need of a particular uh, you know there's no need of appointing a person which is highest which has the highest post, which is responsible for a particular thing. So in that way, what we have is uh, you know a decentralized system which is not really overlooked by one particular person, and power is not shared by many people. Is not shared by just one person; it is shared by many people. So yeah. Now coming to the second point, which is it exists on the blockchain network. So where it is governed by different protocols, and they rely upon smart contracts. So whatever we define in the smart contracts, these help in facilitating those transactions, and in that way, the DAOs are like really important and really essential for us. So yeah, so that's that. So that would be the end of the basic components of Ethereum that we can say. Uh, I just opened the questions. Just open the screen for questions. Just a second. Feel free to just post in the questions. This was it from my side. Like we can just have a good discussion about whatever you guys want. Just give me a second. I'll just open this. The difference between proof of work and proof of stake. So proof of work is basically when we talk about proof of work, it is used to add each block in the blockchain, which is done by miners. So these miners are responsible for doing these different complex tasks and do these computations by themselves for getting hold of these rewards. But when we talk about proof of stake, there's no sort of competition for the there's no competition for this. Like in the proof of work, two people will be running their systems and they'll be trying to outsmart each other because they'll be trying to get the it's just a basic competition of it's a race between how fast I can mine a particular Bitcoin. But when we talk about proof of stake, it is basically someone randomly is chosen for the particular task. So in that way, a lot of computation power is saved, and in that way, not everyone is just trying to run their systems and trying to increase their computation powers. In that way, it's really beneficial for like it has a lot of environmental benefits as well, and Ethereum 2.0 is basically shifting from your proof of work to proof of stake, so we'll be seeing that. It's a very major update, and yeah, and there's also the 50%, 51% rule which comes in play when we talk about the POS, proof of stake, because if I want to add something which is not supposed to be on the blockchain, I will need the access of 51% of the network to do so. So that's yeah, that is very rightly said. That in proof of stake, the validators stake some tokens, and yeah, taking the high, yeah, they get the highest reward. Uh, yeah. If there is any other question about related to the development, I'd like to share this one good resource that I have. Um, if you're trying to get started with development developing of these D apps, and if you're trying to start with the uh, if you're trying to get started with the development of the Ethereum network, you can just look at different Solidity resources. Uh, we say that the development guide on the Ethereum website is the best, but this website called the Solidity, by example, is really good because you get to if you're just trying to look at the use cases and proper examples of some of these snippets, you can just go through this website and you can find a lot of them. They also have different applications which is and their code which has already been made, so you can just open them and go through them and understand how these codes are written. Also, there are some hacks given. So there are a lot of different hacks which can be done, because if I'm trying to store some private information inside of smart contract, people think that you can't really get access to it, but there are some ways to reverse engineer it. So some in some way just trying to identify uh, just how to do it basically. So it is a really good resource. So I'll do one thing. I'll just put this in the chat box. You guys can check it out yourself. Yeah, I've put the link in the chat. What is SHA-256? Yeah, it's a hashing function basically with a digest length of 256. So whenever we are trying to generate a new number, we use the shard duplication algorithm, and it operates on 32-bit words. So we can generate some unique hash functions for different blocks. So in that way, this is like a good cryptographic system that we have. Yeah. So this is a really good resource. Uh, there is the developers guide over the on the Ethereum Foundation's website. I just showed that as well. So if you're just trying to get started with the development, you can just go through the basics of Solidity first, then try to implement the ERC20 tokens yourself. Now, currently there's a lot of development going on in the NFT space. So what you can do is you can try to learn the how to implement the ERC 721s and all those different tokens. So ERC 721s are the the non fungible tokens. And, um, you know you can you can basically create some you can mint some dope NFTs using those protocols. And this is the developer's guide. And this is the developer's guide, which is by the Ethereum Foundation. So this has a lot of documentation for the beginners to get started with. If you're just trying to use some online compilers, you can go ahead with Remix. If you're trying to learn on your system, you can go ahead with Truffle and Ganache for just local deployment. I would suggest to go with the Remix one because Truffle has a lot of different issues uh, when it comes to running on the system because a lot of people experience it, especially if you're working on MacBooks. There are a lot of different hurdles that you might come across. So it is good, and it is relatively easy to do it on Linux. So yeah, so you can go ahead and learn about those, and yeah, and that is from my side. So yeah, that is it.
That was an amazing session, sir. Uh, Participants, if you have any other questions, please post them in the chat so that he can answer them.
And if you have any other questions, you can just reach out to me on LinkedIn. We can have a good discussion about it if you don't have anything right now.